I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Bonus edition.
Bonus edition. Oh, hey,
you missed it.
I totally forgot.
I was like hoping you would forget.
I immediately went to look down at our list of questions. And just, that's so funny.
Well, before we get started with our questions, I do want to address something. So the episode that came out last week about lightning, I noticed when I was doing my review of the episode that both Jam and I said the word master. We actually said it in different contexts, like talking about master bedroom and stuff. But recently what I learned is that the way that we use that phrase in everyday language in the United States is actually rooted in the history of slavery in America. So I've actually been trying to avoid that, and I just didn't catch it until, we'd already put the episode out. So as soon as we realized, we edited it, we took that out because Jam and I really want to be careful about using words that are associated with that part of our history. And we don't want to use words that could make anyone uncomfortable or that uphold that kind of ideology. So we just wanted to address that and apologize, and just wanted to let y'all know that we removed that from the episode.
If you're one of the few that heard it and didn't notice it, or you heard it and you were offended, then we're really sorry. And probably most of you guys had no idea and didn't listen to it after we edited it, but we wanted to let you guys know just in case.
Just in case. And I will say that when I heard that and I was like, oh, I hate that happened, I do think it's a good opportunity to address the fact that, this value that Jam and I hold, that it's really important when we make a mistake to admit it, correct it, and apologize. So we try to do that with our science. If we ever find anything wrong in the science, as soon as we find that, we are going to correct it. And then also in any other area of our lives.
Yeah.
So we just wanted to let you guys know about that in case you noticed that the episode changed or whatever. And now on to the questions.
And the questions are good. We've got some good questions from you guys this month. The first one is from Tim P. Tim asks if CO2 is an attractant for mosquitoes, and if burning a candle is an example of combustion, would citronella candles actually help mosquitoes find you rather than repel them away from you?
Okay, well, first of all, I want to shout out Tim P. He's also a chemist, and he also is a Ko-Fi supporter, and he actually gives roughly the amount that we use every month to get transcripts for the show.
Right.
So that we can give chemistry lessons to anyone who's able to read or listen to our show. And so it's really exciting that we have that accessible option. And the only reason we're able to afford to do that is because of someone like Tim who gives to us consistently. So thank you so much, Tim. But also, that's an interesting question. What I like about this question is that it brings in two different things that we've talked about, which is what is fire and also how mosquitoes are attracted to us. But what I think is that citronella, the actual citronella scent, maybe does some of that masking, or we talked about a long time ago when we talked about mosquitoes that they are somehow able to smell us and are attracted to us possibly by our CO2 emissions.
Right.
And then DEET kind of keeps our volatile compounds from going up in the air and covers up some of that so they can't find us.
Right.
And I think what citronella candles might do is, one, put so much CO2 in the air that we are not unique. Maybe it confuses them. This is just my guess. Yeah. I don't know for sure. It also could be that citronella scent itself could cover up some of our smell in the air or be overpowering.
Right.
And then the other thing I thought is maybe the mosquitoes are attracted to the candle, but I don't think that's right because they don't like smoke.
Right.
So those are my two thoughts.
You know what's so funny is it's been just long enough since we did those episodes. Like, you started saying some of the terminology and stuff again. And I was like, oh yeah, I remember that. But it's been a while. I need to re-listen to them probably. And it's mosquito season here in Texas. It's starting to become the time of the year where it's really bad. And so this is an interesting question to be asked right around the time where it starts to be relevant again, The
thing that sticks out in my mind is they had all these people sleeping in tents, and they were checking how many mosquitoes followed them, I think, when they would leave to go to the bathroom in the middle of the night or something along those lines. And there were way more mosquitoes around the pregnant lady or the pregnant ladies than the non-pregnant ladies. And I was like, Whoa.
Yeah.
Pregnancy makes you that much more attractive to mosquitoes. That's the big thing I remember. Because
Yeah.
I think you have more CO2 emissions and your temperature is raised and all these things.
Yeah. Yeah.
That's also relevant to your life right now.
Mm-hmm.
Since there's a pregnant lady who lives in your house.
And who, when she is or is not pregnant, always seems to attract more insects than I do anyway, no matter what.
Probably because of her CO2 levels.
Yeah, it's got to be. I try not to have anything to do with CO2 if I can help it. You know? I breathe in oxygen, but I try not to breathe out CO2 if I can help it.
Oh my gosh.
This next question is from Renee C. And she asks, where did sand come from?
Okay, this is really relevant to an episode that you haven't heard yet, but we've already recorded. Jeremy and I are in the process of getting ahead of the calendar because he's having another baby come into this world and I'm taking a long-term trip.
Right.
And so this goes really well with our volcano episode that's coming up. I'm really excited about it. So sand is actually primarily silicon dioxide. And if that sounds familiar to you, glass is also silicon dioxide. So there's that Sweet Home Alabama thing where it's like when lightning strikes glass or strikes sand, it makes glass.
Uh-huh.
So it's basically that. Do you remember that?
I don't know what.
It's from that movie Sweet Home Alabama with Reese Witherspoon.
Okay, got it. I was like, I'm trying to think of the lyrics of Sweet Home Alabama, the song.
No,
I was like,
You're
that
like,
doesn't
what?
sound familiar to me at all. I haven't heard that song in a while.
Lord,
but
I'm coming home to lightning. No, that's not right.
when it strikes sand, it turns to glass. Yeah.
So that there is just a lot of silicon dioxide naturally occurring. Actually, I believe silicon is the second most and oxygen is the first most abundant element in the crust. So then sand is just really worn down small particles of that, basically.
Right.
So that's my best answer for where sand came from. But if anyone knows more, possibly let us know so that we can share with other people.
Yeah. Interesting. This next question is from Rebecca T. Rebecca asks, what does it mean for light to scatter? Why do we only see blue in the sky from scattering? Don't other colors scatter, but there's so much blue that it covers up the other color frequencies?
Okay, so that's Rebecca. I encourage you to go listen to the Why is the Sky Blue episode. When I think about why light scatters or what does it mean for light to scatter, I think of light as a wave. And so maybe you could imagine something like a wave in the ocean. If it hits something, the wave doesn't keep moving in the way you expect it to move anymore. The water would sort of spread out. You know, if a wave comes up against a pole or a oil rig or something, you know, the water molecules will move out. And so I think light does something similarly where it hits a molecule in the air or wherever, and then it's literally the waves go in different directions. It's scattered. And light waves do come at us in all different directions. There's some that oscillate up and down, up and down. If you imagine just wiggling your finger up, down, and then wiggle your finger side to side, side to side, side to side. Light's coming at us from all those different angles, even like at a, what is this angle?
Diagonal?
Oh, yes, at a diagonal. You know, it's coming at us at all these things. And actually what polarized lenses do, I think we had an episode about this too, is they filter out all the light that doesn't come in a specific angle. So it's literally just scattering the light waves around. But in the episode about why the sky appears blue to us, it's actually because all of the different individual colors that make up white light have different wavelengths. So when they get scattered, some can go further than others, essentially. So we're able to see more blue, even though all of them are being scattered in the sky.
Right.
But that goes really well with our question about the clouds. So that ties in really well with our episode about why clouds are white. And also, you can go back and listen. I think in March, we released the episode about why the sky is blue.
Mm-hmm.
Those are good questions. Thanks, Rebecca. I actually am not great at light. The wavelengths of light get almost too much into physics for me, where it can be kind of hard for me to fully understand and communicate them. So I hope that was understandable and helpful.
And it makes sense, though, too, because like there's so many overlaps with different disciplines. You know, it's like several of these things end up in different sciences where you're trying to learn from the same natural phenomenon or whatever.
Yeah. And there's this idea in chemistry that, is it electrons? They have what they call a wave particle duality.
Mm.
So wave forms follow a specific type of physics, basically. And then particles like large scale, I guess large scale is not the best word, but basically bigger things have enough mass to them that they follow classical physics.
Mm.
And then I think it's like electrons are right in the middle of that. And so you have to learn about how both function to understand how electrons move.
Dang.
And the math behind electrons and how we figured out where electrons are likely to be found around a nucleus. And it's very confusing. And I hung on through that class for dear life.
Yeah.
But yeah, so that is, waves move differently than classical physical things do that we're used to seeing. And so it can just make it hard, I think, for me to be able to fully comprehend it and communicate it.
Yeah. That makes total sense. This next question is from Fletcher in Australia. Shout out Australia.
You've been there, haven't you?
Not technically. I've been at the airport, which I don't count.
Yeah.
But I'd love to go. I've been in New Zealand, and so I've been to the part of the world enough to realize I want to go to other places in that part.
I'd love to go to Australia and New Zealand. I really want to see the Great Barrier Reef before it all dies.
Dang. Sad,
but also beautiful.
Yes. So Fletcher doesn't have a question about that, but does have a really interesting question. Is using heat to cook an egg an endothermic reaction? Why or why not? Is there a contrast to using a whisk to deform the egg proteins?
Okay, Fletcher. Yes. Gen Chem right here. So first I'm going to define endothermic versus exothermic. Endothermic requires heat to work, and exothermic releases heat for the process to work. So this could be chemical or physical processes like reactions, or even just melting or boiling.
Mm-hmm.
So actually melting is you're putting heat in, so that's endothermic, and freezing, you're taking heat out, so that's exothermic. You have to remove, or heat is being let out and being chilled down to get solid.
Right.
So cooking an egg, I would say, is endothermic because you're putting heat into it. You're literally heating up a pan and letting that egg cook.
Mm.
Now, there may be some parts that release heat. Sorry, didn't mean to.
Yeah.
There might be some parts that release heat in that process, but overall, the process of getting an egg's proteins to denature requires heat or energy to be put in. And the same thing is true if you're denaturing the proteins like in the egg whites and you're making like a meringue or something. You're putting work in to break the form of the protein and to get it to denature. So you're putting energy in, and you are mechanically still denaturing the proteins. You're just putting energy in that way mechanically versus putting energy in with heat.
Right. That makes total sense.
That was a good question.
And we do have an episode about eggs, Fletcher.
Yes, and it has one of my all-time favorite analogies Jam has ever done.
And it had a guest in it, like one of our second ever guests that we've ever had, really.
I think the only male guest we've ever had.
And the only non-expert.
Yeah.
he's a lay person's expert on eggs, but not the science of eggs. Anyway, you should listen to that episode. I think you would find it very interesting if you have kind of other egg questions that you've been thinking about.
My brother really wants to come on as a non-expert to talk about wine.
Oh, interesting.
Yeah.
I don't know anything about wine.
He knows a lot about wine, so he probably would be better at asking questions than you. I think he even started sommelier training or something.
Dang. Wow.
Yeah, he thinks that is very interesting, and there's a lot of chemistry in wine.
Yeah.
So that's a possibility in the future.
Nice. That'd be great. This next question/statement is from Sophia. She said, I wanted to ask if you have a list of the chemistry topics that you've covered in your episodes. I know you organize the titles by everyday topic, but if you have a list of the chemistry topic that corresponds to each everyday topic, that would really help the planning process for teachers.
Sophia sent us a nice long email. Sophia's a teacher, and I was very excited by a lot of things that came up in this email. So for this list, yes, Sophia, technically right now it's not on our Chemistry for Your Life website yet, although we're working on launching a new Chem for Your Life website. So exciting. But on my link tree, so, and maybe I can put it also on the Chemistry for Your Life link tree too, there's basically just a link to a Google Doc where I have started this list. So I have a link tree that's linktr.ee/organic Melissa, and you can go there. Or the Chemistry for Your Life one is just, I think, the same link tree /Chem for Your Life. And so I can work on making sure that that Google Doc is linked there too. So it's very informal. It's not a fancy list. We're working on getting one organized, but if anyone's interested, you can go to my link tree and eventually the Chemistry for Your Life link tree, and you can look on my list there. And Sophia also talked about how she's a teacher, and she said she came in at an exciting time to where she's teaching because they're rewriting the curriculum. And that's always very exciting to me. I strongly believe in rewriting curriculum. And so they're trying to help the students learn better by doing more hands-on activities and more clear connections and topics to everyday life. And Sophia asked if either Jam or I have ideas to help out that process. So for me as a researcher, and then Jam for you as someone who is not in science, what keeps non-scientists engaged?
Interesting.
So I'll let you go first, Jam. What do you think as a student, as the non-scientist there?
I bet if I thought longer about this, I might have more ideas, maybe. But one of the things that is exemplified in kind of some of the tactics we've taken with the podcast is that we start with connecting to an everyday life question, which I realize when you're planning out a curriculum kind of on the back end of it, you want to make sure you're touching on the right principles and stuff like that.
Yeah.
But I think I get hooked in by knowing that something might help me understand a question that I wonder about.
Right.
That does relate to everyday life, even if along the way we actually touch on tons of different, like actual different chemistry principles that you really want to make sure you spend time on in your curriculum. But I think it's easy to hook me if you start by doing sort of like taking a lot of steps toward where I already am in my everyday life.
Yeah.
But then you've got me, and I'll come along for the ride wherever else you go in pursuit of what started out as answering a question about everyday life stuff. So that's my off the cuff answer, is to do that wherever possible, wherever it makes sense to do that.
Right. Well, and I think that's definitely something I want to incorporate. Part of my research is asking students about organic chemistry, and my big thoughts on that area, whereas definitely that's my area of expertise, is reducing the course curriculum so that they can dive deeper. That's a big one. Just because slowing down gives you more room and space for them to do those activities and for them to wonder and seek out answers and to connect it to everyday life. So if I was revamping my course curriculum, I would cut out some things that seem extraneous or that don't come back up a lot and really focus on what do they need to know for the next class, but also what are things they're going to actually take with them.
Yeah.
And then the other thing is what you mentioned in your email about students doing less listening and taking notes and more activities. That's something called active learning. And studies show pretty clearly that students doing active learning and not just listening to a lecture are going to be much more effective in their learning process. So letting them, do group activities. There's something called scaffolded group activities. Those are great ideas because then they are getting to do things. And I do remember in my graduate school class, I did a study on women in engineering, and I actually think it was specifically Black women in America in engineering, and why some of those populations were underrepresented in engineering. And one study talked about how using lecture style learning rather than experimental and them kind of trying to figure stuff out on their own, students believe that everything's already been discovered. So there's not a space for them in this field because other people have already found things out.
Oh, I see.
So we teach science as if it's finished and here's the facts that you need to know, instead of teaching science as a way of exploring the world and understanding more about the world.
Right.
And when you teach science in the way of it's finished, here are facts for you to learn, it keeps those underrepresented populations in STEM more likely to think they don't belong there.
Yeah.
But letting them participate in scientific inquiry and thinking and making observations and drawing conclusions, that actually helps them believe that there's a place for them in science and that they can contribute.
That's so interesting.
Yeah.
It makes total sense. It's like no one's saying it verbatim, like, hey, everything's already discovered.
Right.
But it is unconsciously being communicated by the style and the kind of way that the topics are delivered.
I wish I could find that paper again. I might be
Yeah.
able to and send it. But also, you know, there's a lot about how learning is not just a cognitive process, it's also an emotional process.
Yeah.
And feelings, how you feel about learning, can impact your experience. So piquing that interest is going to be something, as well as helping them build up their confidence and helping them learn how to use problem solving skills so that they have that self-efficacy.
Yeah.
All those things will really help students develop what they need, not only to be successful in making observations, drawing conclusions in your class, but also in college. Some of my college students come into college not being able to make statements with causal relationships where they can say, because I saw this, I can draw this conclusion. Or even like, you know, about concepts. They're just not great at connecting those because they don't use their problem solving skills a lot at an earlier age. They do a lot more of learning and regurgitating.
Yeah.
So pulling the emphasis back from that and instead working with them, making observations, thinking, drawing conclusions, that's going to be a much better goal for them.
Right.
And then the last thing is, I don't know a ton about this yet. My research is shifting in this direction, but I'm starting a new job in the fall where I'm going to do work on something called systems thinking. And that's an idea that you can take a system such as climate change or sea level rise and use that system to teach all these different chemistry concepts. And then students don't think of, oh, this chemistry concept in my classroom is one thing, and then this climate change is something totally different. They're able to translate the classroom into real life. But it can be difficult to implement that, and studies aren't there. It's sort of an emerging field, I would say, but it is, I think, one of the biggest openings. You could even do it on a small scale of using the system of cooking eggs for intermolecular forces, something like that. Talk about heat, talk about how molecules move, and help the students think about everything at all these different levels.
Yeah.
So that's my rant. I love it when people ask me questions about changing curriculum.
Yeah.
But I'd like to your thoughts too, Jim, because they kind of go with what I've seen actually happen in research as well.
Yeah. Dang, very cool. Very good question.
That is a really good question.
This next one is from Renee C. also. She asks, what is a bucket list vacation for you?
Well, guess what? I'm going on a bucket list vacation this summer. That's part of why
Nice.
we're recording ahead. My husband and I are going to Banff National Park, and we're going to see Lake Louise and Lake Moraine, which are two places I've wanted to go my whole life. And I'm really, really excited. It's partially celebration for graduating, and we never took a big trip, just a small trip after our honeymoon. And so it's kind of like all of that at once.
Yeah. That's awesome. I definitely have wanted to go there as well.
Yeah. I'll go back with you if you want.
Okay, deal. I've also really want to go to Alaska.
Yeah.
But a bucket list vacation that some of you guys already know about if you've been listening since the beginning of the podcast. But my wife and I, after we've been married for 5 years, went on a trip to New Zealand. It was literally like 3 months before the pandemic started. So it's kind of like, we couldn't have known the timing was good to go on that trip when we were able to go, where we had to wait a while. But went to New Zealand. We spent like 3 weeks there.
Didn't you rent a camper van?
Rented a camper van, drove all over the South Island and the North Island, the two main islands, I should say. And then, it was super fun. It was something we've always wanted to do, and we thought we have to get this in, not like bucket list, not like before we die, but more like before we have a kid.
Yeah.
We kind of thought this will be the most doable it's going to be for us in the near future.
Yeah, probably you got about 10 years before you could cover close to the amount of ground you can cover without a kid.
Yeah, exactly.
After having a kid.
Yeah. Or like wait till all the kids graduate and go on a crazy trip again, something like that. You know?
Although I have heard I've heard parents talk about that traveling with kids is actually still really good and fun. It's a different type of traveling. Like you guys went hard.
Yeah.
For 3 weeks. You were hiking all over the place, living out of this camper van. That would be a hard adjustment for a young kid.
Oh, totally.
But there's some other traveling I think kids would really still enjoy.
Yeah, definitely. Yeah, it would change what we did and how we did it and what sites we wanted to see and all that kind of stuff. It's still very doable. But the way we wanted to do it, it was best that we did it when we did. So that's one that we did get to check off, which is cool. So
yeah, this is my first, I guess this is my second bucket list vacation. The other place I really wanted to go is the Swiss Alps in Denmark, and I did that with my mom.
Oh, yeah.
So, yeah, really thankful for that. Whenever I go on big trips like that, I think, I'm spending so much money. Is this worth it? And I think now having my mom passed away, it's like, would I ever get 2-3 times that money back for not having that time with her? Never. Like it was, the memories are absolutely worth it. So we kind of feel that way about this trip. And I was thinking, oh, this is so much money. And then I thought, well, I'll have these memories for the rest of my life and it's going to be so sweet and special.
Yeah. We also got some really good questions from you guys that cannot be answered quite yet.
Yes.
Do you want to share some of those that are going to be?
Yeah. So there was a lot of questions that came up that I think are going to have to be future episode, but I still wanted to shout out. Kate asked about how tattoo removal works, but also how even does regular tattoos work, not just even the removal. Tim asked, and so did someone else actually, asked a thickening sauce with a roux. Is that an example of polymer chemistry? Renee asked, why do baby animals make us happy? And there is actually some chemistry that gets released when we see cute babies of all different kinds. And then Wendy asked, why does water expand in low temperatures while other substances will contract at lower temperatures? And that's a really good question. We're going to talk about that and why water floats in an upcoming episode in July. And then also Wendy and Renee both asked about the ions in the sea. So there's all kinds of really good episodes that they're great questions, but they're not great for Q&R. So we just wanted to go ahead and shout those people out. And thank you for your questions. And those episodes will be coming up soon.
Nice.
And we also wanted to shout out our Ko-Fi supporters. I already mentioned Tim before had really that enabled us literally to get transcripts made, but also we have so many other people who support us on Ko-Fi and enable us to do things like go to a conference this summer and have guests on and things like that.
And those people are Jacob T, Tim P, like we already said, a mystery Ko-Fi supporter. You know who you are. And there's also
2 mystery Ko-Fi
another
supporters.
One. So you guys know who you are. You don't know who the other one is, but you know who you are. Stephen B, Chelsea B, Brian K, Christina G, and Hunter R. Thank you guys so much for your support. Some of those are people who support us monthly. Some of them went and gave a one-time donation. It all helps. And every amount of a cup of coffee donated to help support the podcast is really helpful. So thank you guys so much.
Definitely. And I did want to say this is our June Q&R. And for our July and August Q&Rs, we're going to be doing something a little bit different because Jam and I are both preparing to take leave, for me to go on my trip with my husband and for Jam's son to be born to have time on paternity leave with his wife. So we won't be doing a traditional Q&R again until September. So if you have burning questions, still send them to me and we'll do a Q&R starting again in September. But thanks for all these questions. They were so great and I had a lot of fun writing this episode.
This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. I would like to give a special thanks to E. Robinson, who reviewed this episode.